Hello, it's Dr. Bhatt here. Today, I wish you to make recall about my earlier presentation or video relating to uh, precision and accuracy and certain details about quantitative analysis. We have understood what is meant by precision and accuracy. Therefore, now the question is how to make our results precise and accurate. And as known to us, whatever experiments we carry out quantitatively, we have to put it up in numbers. It may be any number which is normally provided to us through certain experiments or by way of instruments we are using it. And these numbers are nothing but in certain digits designed together or jotted together in a way to give a number. We know that a number is nothing but an arrangement of digits in a particular fashion. For example, here you find 1, 2, 3 written here, and mathematically we call it as 123 or 123. Now, this number is made up of digits. So, these digits are non-zero digits. They are not zero. We call them as non-zero digits. And all these digits are useful to us, meaningful to us, and therefore, if these digits are meaningful to us, we call it as significant figures. So, what is the use? Before I give you certain other details about significant figures, I would like to tell you what is the utility of significant figures or identifying significant figures. The utility of significant figures is that it communicates precision in our results, precision in our reporting of the results. It builds up how confident we are about giving the results. And if the accurate values are known to us or the accepted value are known to us, it also gives us an idea how closer we are to the accuracy. We want to be precise and accurate. That is the basic of reporting any quantitative analysis, any quantitative result. Now, whenever we use an experiment, we perform an experiment, we use certain instruments, maybe a simple burette, maybe a pH meter, or maybe any other type of instrument, conductor meter, and other. Now, these values, the results, are directly given in the instrument, and we note it down. But we need to understand that whatever may be the instrument, it has certain built-in inaccuracy. Certain inaccuracy is there. It creeps up in a number of ways, and the instrument is always not very accurate, might be very close to the accuracy. So that has to be also considered. And the result or the report, quantitative report which we give, has to be reviewed. And this review of the result is again done through significant figures. Now, The same experiment may be carried out by a number of workers or researchers, and getting similar results for each by each of them is also necessary. That is known as data reproduction. The data production or reproduction should be similar. कई लोग मिलकर काम कर रहे हैं, लेकिन उसी एक्सपेरिमेंट को उन्हीं परिस्थितियों में अगर वो कर रहे हैं तो वही रिजल्ट आना चाहिए. So that is possible by the use of significant figures. Now I'll just give you a few. Now these significant figures are determined by following certain rules. I'll just simply give a few examples here, which will be again reproduced in the notes I provide later on. And these notes have to be preserved, saved for subsequent calculations, understanding about the significant figures. Now, suppose there is a figure as 1, 2, 3, and I have already made it clear. Mathematically, it is 123. And since these are non-zero digits, all non-zero digits are meaningful to us, and therefore they are significant. Suppose another case of leading zeros, zero before the significant figure. Leading, we call them as leading zeros. Suppose I write 0, 0, 1, 2, 3. So 0 before a significant number is never significant. 0 before a non-zero digit is never significant. चाहे भी जितने जीरो इसको पहले लगा दीजिए, 1 के पहले वो significant नहीं है. Suppose I write 0, 0.123. Point means decimal. 0, 0 decimal 1, 2, 3. Again, two leading zeros are there before the decimal point. Therefore, even under this condition, the zero is non-significant and the value has got 123.123 and 3 significant figures are there. Please be careful to listen it. 0.123 will have 3 significant figures. And suppose I put a 0 here between 2 and 3. The number becomes 1203. That means a 0 which has been captivated or which had been jotted or written between two significant figures becomes significant. 1203 will have 4 significant figures. 1203. How many significant figures? 4 significant figures. And suppose I write 1.23, again a case here, putting a point after 1 decimal point. Decimal point is never considered as a significant. It just provides a place of a particular number, a digit. So it is again 3 significant figures. Suppose another case, 123.01, 123.01. If this is the number, then how many significant figures will be there? There would be 5 significant figures. Why? Because 0 after a decimal point becomes significant. Before a decimal point, leading 0 is insignificant. And suppose I write a number in terms of scientific notation 123 into 10 to the power minus 4 means 0.000123. That is the actual value. And in scientific notation, we write as 123 into 10 to the power minus 4. Then this 10 raised to power certain value exponent is never significant. Again, the number of significant values here will be 3. So that way, certain rules are there. The rules have been provided in the notes I am giving a little later. Please go through it, and all details I have explained here, mentioned, and it would be worthwhile to get a practice of significant figures because we are required to calculate or to identify the significant figures, and at the same time number of significant figures. What are the significant figures we have to identify, and we have to report the total number of significant figures. Well, that's a practice, and of course we know that practice makes a man perfect. We have to practice based on these numbers and identify significant figures. We shall gradually learn more about significant figures and putting up the results by rounding up the results and including calculations based on significant figures in our next presentation. So here it is. Please go through it. Utility of significant figures, whatever I have given here. Precision communication, error estimation, and consistency. Multiple people working should get the same results after the constraint. That is consistency in working. It reports how confident one has in the digits we are providing. Error estimation. This is very important. Many times we are precise, but and at the same time we might be close to the result. Accuracy. If the accepted value or the accurate values are known, we might be close and to the accurate value and precise. But knowing the accurate value and our precision, there might be some error which has kept in, which is normally supposed to be a human error. So what is the percentage error we can calculate? So that's the advantage of significant figures. More significant figures, less uncertainty. Then here is a necessity. I have already explained that there is certain degree of inherent accuracy in most of the instruments. So in order to maximize the accuracy in result, one has to review the observed reading and use significant digits. Other digits are insignificant and they are to be ignored. Then here it is. What is meant by significant digit and a number, and the digit is meaningful experimental to the known and significant digit. All this I have explained earlier, and here it's very important. There are certain rules for inferring significant number in a given number. Significant digits, I mean, significant number should not be the word here. It should be significant digits in a given number. Non-zero digits are all significant. Captive zero digits, captive zero in between non-zero are significant. The example I have already made it clear. Suppose it is 10.07, four significant figures. Leading zeros leading zeros, zeros to the left of the non-zero are not considered significant. Means they are insignificant. For example, 0072.00722. Two significant figures are there. So that way, the rules you have to practice, you have to go through it. And trailing zero. Trailing zero means a zero after a significant number with a decimal point. That is known as trailing zeros. पीछे आने वाला. Okay. They to the right of the decimal point. They are significant. Now, one thing is again important, that exact number I give you here as a coefficient. 2H2 plus O2 is equal to H2O. This is a simple equation where two molecules of hydrogen combined with one molecule of oxygen and form two molecules of water. And coefficient 2 and 1 are represented here. It has infinite number of significant figures. That is very important. Suppose I make it 3, I make it 4, 4H2, then what will happen? O2 will be 2O2 and will give 4H2. So all these values, what you are getting is significant number here. That's there. And then here is a table which represents the significant figure, illustration of significant figure and non-significant digits here. 3, 6, 500. Actually, it has three significant figures. These are 3, 6, 5. But suppose I write 3, 6, 500 as placed here. Again, trailing zero is not significant until and unless there is a decimal point. So the number is 3 again. Suppose I write 3, 6, 500 point. Simply I put a point here. Point means after that there is a zero. So how many significant figures are there? 5. 365.04. So it may be 3, 4, 5 depending upon the conditions. Zeros at the end of the number, right hand side may be significant or not significant. These are the cases when it becomes significant or non-significant. This particular case I have provided to you especially to make you understand that zeros at the end of the number means right hand side. It may be significant or non-significant depending upon how it is placed, and that is represented by a decimal point. And like that, here are certain numbers. All the rules, applicable rules are given here, and you can make out the total number of significant figures as I have already explained. For example, 0.0067. There is a decimal point. After that, two zeros are there, and two non-zero digits are there which are significant. 0 is not significant even after a decimal point. It is simply a placeholder of the significant region. So zeros after the decimal point are considered as placeholder only and are not significant. So these are the rules, application of rules here. And 680, the whole number digit is considered significant, and that way you should go and find it out, an illustration this way. Okay, we stop here and then we shall continue again with significant figures through a practice relating to its calculation. Calculation means addition, subtraction, multiplication, division, or simplification. of a mathematical formula using uh, significant figures and putting up the result. Remember, result based using significant figures makes us more precise and closer to the accuracy, provided the accurate values are known. We can calculate the errors made in our experiments. And okay, thank you. We shall be back again with certain other details about calculations, rounding up of significant figure, etc. a few days after. Thank you. Stop here.